So now that we have a good understanding of average velocity, we're going to talk a little bit about what instantaneous velocity is. And this is going to become exceptionally important for graphical analysis or for situations where a lot is changing. So in order to consider instantaneous velocity, let's consider a situation where you're going on a road trip. And I really like this road trip. Actually, I don't. My sister lives down in LA. I go visit her periodically. It takes a long time to drive there. Here we can see a situation where our good buddy the hedgehog is going to be driving from Galt down to Los Angeles. All right, and we can consider what this trip is. This trip is going to take us 5 hours and 20 minutes, and we're going to be traveling 362 miles. So 520 minutes gives us a value of 1.92 times 10 to the 4th seconds. And this value of 362 miles gives us the value of 5.8 times 10 to the 5th meters. That's how many meters are actually being traveled there. So that means that our average velocity for this trip is going to be 30 meters per second south. Or if we converted that to kilometers per hour, we're looking at a situation where it's 110 kilometers per hour to make that trip. For simplicity's sake, we're going to imagine that our hedgehog friend is traveling perfectly displaced. All right, he'll be perfectly 362 miles, or 5.8 times 10 to the 5th meters displaced when he's done with his trip. So now that we know that this is the average velocity, consider this road trip. Right? This is the average velocity that we're taking a look at right here. All right, so consider this road trip. Anytime you ever take a road trip, it's not like you're able to put on the cruise control and travel the same speed the entire time. What really happens is our hedgehog friend, as he goes down, look, he's going to hit some road construction. So maybe up here he's going to be driving 5 kilometers per hour for a little bit. But then when he makes it down into the Central Valley where there's a lot of nothing going on, maybe he'll get his speed all the way up to 150 kilometers per hour, which is really going to ruin his day because the cops like to hang out there and make sure to give you a speeding ticket if you speed too much down there. So these values over here are how fast he was going in an instant. So we call these values over here instantaneous velocity. So we do have these two completely different vocabulary terms now. Average velocity, which we know from before, and instantaneous velocity, which is our newest consideration. So let's go ahead and let's give these definitions. Alright, so average velocity, right, is derived from the total displacement that happens in the total time that's elapsed. Right, that's our average velocity. Instantaneous velocity is whatever your velocity is right at that instant. And the way that we write that is we say that your velocity, right, this is what it is as the time that's changing. Right, so instead of saying in 5 hours and 20 minutes, as the time that's changing is approaching 0. That means right at that instant. This is what your odometer shows you, is your instantaneous velocity. As the time that's elapsing is approaching 0, all right, then we're going to consider what your change in position over time is in that instant that's approaching 0. Notice one of the only differences in these two equations is that you've got v bar versus a total velocity. And so this is how we represent instantaneous velocity.